Hello, everyone. Thank you for joining us for today's session. My name is Iskia, and I am the facilities coordinator for the Redmond Reactor Space. Before we start, we've got a few things to go over, so please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will be shared throughout the chat. The session is recorded and will be available in 24 to 48 hours on the Microsoft Reactor YouTube channel, which brings us to today's session. It's going to run approximately for 1 hour with time for questions throughout. So I will now turn it over to our speaker.
Hello, thank you, Asker, for the nice introduction. Welcome everyone to this new reactor session. Good morning, good afternoon, good evening, wherever we are in the world. Today we are going to talk about computer vision and how large foundation models improved computer vision. In particular, we're going to see all of these on Azure. So let's see if perfect. We have the deck. Awesome. So let's jump directly to what's in for today's session. As Askia said, we have about 1 hour, and I'm going to introduce briefly myself. Then we are going to jump to computer vision. So what's computer vision and how you can use computer vision on Azure. We are going to see large foundation models, in particular, large foundation models in vision applications. And we're going to do also a pair of examples. I'm going to demo how you can use computer vision services, both using the Vision Studio, so with the graphical user interface, and how you can add computer vision capabilities into your app using the APIs. Who am I? I'm Carlotta Castelluccio. I'm a cloud advocate at Microsoft, and I'm an artificial intelligence and machine learning ambassador. I advocate for AI students, AI educators, and learners in general. So whether you are an experienced professional wanting to jump in this AI domain or wanting to switch to an AI career, or you as a university student, I'm here from you. I love arts in all its form, and in this slide you can see at the top myself in the Monet room at Orangery. So I really love art, painting, and cinema, music, everything art related. But let's jump. Let's go ahead. I wanted to remind you that this session is part of the Microsoft Learn AI Skills Challenge. This program is designed to enable you get a head start on immersive and curated AI training across Microsoft products and services. So whether you are new to artificial intelligence or you're looking for a career change, you can choose between 4 AI-themed cloud skills challenge. You will see this includes machine learning operation, MLOps, AI builder, and cognitive services. So what's a cloud skills challenge? It's a gamified competition experience which enables you to go through a predefined collection of modules on Microsoft Learn, which is the biggest platform owned by Microsoft for training. If you complete at least one of the 4 challenges before the 14th of August, you'll be able to claim a certificate of achievement that you can share with your network. While going through the challenge, you will also have a complimentary selection of live workshop as this one, offered in multiple languages, not just English, and multiple time zones. So make sure you check the list of the upcoming ones and mark on your calendar the ones you're most interested in. The events are all recorded, so you can also watch them at your own pace on demand. If you need support from the community or from Microsoft experts while you go through this learning journey into AI, or if you just want to engage with other participants, you can join a dedicated Discord server. And by joining the Discord channel, you also discover about the Pitch Your AI Solution contest created for you to submit an idea through a 3-minute pitch video for an innovative AI project. So you can learn more about everything I've just said, and you can register from Microsoft Learn AI Skill Challenge using the link in this slide that will be also pasted in the chat. So now, since I've talked a little bit about me, I want to know more about you as well. I have for you a poll, an icebreaker poll. Let me see if I can share with you the link. Yeah, so here's the link that will be pasted in the chat as well. If you go to aka.ms/ai-skills-poll, you will find a three question poll, very quick, just for me to know more about you. You can also use this handy QR code on the screen, and you can join from your mobile. It's very easy to join from your mobile as well. So please join the poll from your mobile, from your computer, as you prefer. And I'm going to share with you what are the questions you are going to see when you open the form. You will have 3 questions. As I said, I would like for you to share if you're already registered for the Microsoft Learn AI Skills Challenge, if you already started Microsoft Learn AI Skills Challenge, and of course you can share. There are in the form 3 close-ended questions, but if you want to share more, feel free to use the chat as well for adding comments. I would like also to know if you started the challenge, which challenge have you started, or if you haven't started yet, which one you would like to start. As I mentioned before, there's 4 AI-themed cloud skills challenge. You have 1 related to machine learning, 1 to MLOps, 1 to cognitive service, and 1 to AI builder. So which one you would be more interested in, or which one you already started? You had already started. And the third question is, how would you rate your AI knowledge? This is again just an icebreaker. All level of knowledge are welcome here. Just for me to know more about you. Rate your AI knowledge with 1 within a range from 1 being beginner to 5 being expert. So expert could just mean that you, for example, already created some solutions integrating AI services, and beginner that you just started your learning journey with AI. Oh, perfect. I see already some answers coming. Again, if you want to join if you just jumped in the live streaming and you want to join the poll, just use this handy QR code or the link in the chat and join the poll. There's 3 questions that I would like for you to answer just to learn more about you. So here we have 77% of people that already have registered for Microsoft Learn AI Skills Challenge. Wow, that's huge. Very happy. And I hope that the ones that answered no are going to register soon, because I think it's a very useful experience for you if you want to kick off your AI learning journey. And of course, everything is free. Every content is free. So I really encourage you to join this experience, to interact also with the other participants and learn more. Thanks for keep answering to the poll. So let's go to the second question. Okay, so the top answer here about which challenge have you started or you'd like to start is machine learning. Awesome, great to hear you all are interested in machine learning, learning more about machine learning. And then the second choice is MLOps. this is interesting as well. I also think that MLOps is very important. It's complementary to machine learning. It's good to have an end-to-end idea of how to not just build a machine learning solution, but also maintain, deploy, and have a continuous pipeline of integration and deployment, similar to what we do with software. And let's see the last one. So how do you rate your AI knowledge? Okay, I see that the average is 2.2. That's great. Again, there's no wrong or right answer here. I just would like to know more about you. And thank you so much for joining the poll. I think it was fun. Now let's come back to our presentation, because I would like to get started with computer vision now. And just to recall you, what are the learning goals for today's session? We are going to understand how generative AI enhanced computer vision service on Azure. And we are going also to learn how to integrate image analysis and generation capabilities into your solution. I want also to remember to recall if you have any specific questions throughout the session, please feel free to paste them in the chat. I will try to pause from time to time to see if there are any questions and to address your curiosity or doubts. Awesome. Let's jump to computer vision on Azure. So computer vision, first of all, what is computer vision? Most of you answered that you are beginners in AI, so I don't want to make assumption about the terminologies or the AI terminologies I'm going to use throughout the session. So let's start with what is computer vision. Computer vision is a core area of artificial intelligence focused on understanding the information contained within visual data sources, such as images and videos. This branch of artificial intelligence aims to emulate human visual perception by using advanced algorithms to recognize the content and the context of optical inputs. So to an AI application, an image is just an array of pixel values, similarly to what you see what you see on the screen. So these numeric values can be used as features to train a machine learning models that make predictions about the image and its contents. So the model is trained in a way that it can extract a pattern starting from these arrays of data, which are the features, and it's able to generalize those patterns to unknown data. However, training this kind of machine learning models, so computer vision type of models from scratch, can be very time intensive and can require a large amount of data that in some real world scenario we don't have. So within the AI services offer on Azure, there's a service called Azure AI Vision, giving you access to pre-trained computer vision capabilities. Here we are. So we have said that computer vision aims to allow computers to gain understanding of digital images. But what does it mean to understand in this case? Let's see some practical application of computer vision to make things clearer. So, and these applications I'm going to describe now are all scenarios that can be addressed using the Azure AI services, Azure AI Vision service in particular. So potential use cases for Azure Computer Vision include description and tag generation, starting from an image, which means determining an appropriate caption for an image, and identifying also relevant tags that can be used as keywords to indicate its subject. You can also perform category identification, so identify an appropriate categorization for the image, and, for example, recognize any known landmarks. So category identification is similar to tagging, but in general, when you tag a picture, you have more tags for an image, while category is just a label assigned, a single label assigned to an image. And then other kind of typical applications of computer vision are object detection, face detection, or brand detection. So the model is able to detect the presence of specific objects or human faces or brand logos within the image, and also locate where they are specifically in the image and return the coordinates of a bounding box in which the object, the face, or the brand logo are in. Then another classical application is optical character recognition, which is an application enabling the model to extract image from text. It could be handwritten text, could be typewritten text. With optical character recognition, we can extract text from the image. And then another application is spatial analysis. With spatial analysis, we can identify people or objects, such as cars, for example, in a space, and map their movement within that space. So in this case, we are talking about video streaming as input versus static images as input to the service. In addition to what you see in this slide, there are also other possible use cases of this service. For example, moderation rating, which determine if the image includes any adult or violent content. You have smart thumbnail generation, so you can identify the main region of interest in the image to create a smaller thumbnail version from the original image. And then you have image metadata, color, and type analysis, determining the format and size of an image, its dominant color palette, and whether it contains clip art. So a lot of applications for Azure AI Vision. This is an overview of what you can do with this service in the computer vision domain. But to get started with Azure AI Vision service, first thing first, you need to provision a computer vision or cognitive services type of resource. In fact, you can provision computer vision as a single service resource. In this case, you are going to choose the computer vision resource, or you can use the computer vision API in a multiple service cognitive services resource, depending on whether you need to use a single service into your solution. And in this case, we are going most probably to choose the computer vision type of resource, or if you need to combine multiple cognitive services, so you can create a single resource to centralize resource management, cost management for your solution for all the cognitive services you use into your solution. Anyway, you need to provision an Azure resource in your Azure subscription. And then once you have the resource in your Azure subscription, you can then rely on the Vision Studio graphical user interface, which is a website. So similar to the Azure portal, you have a specific portal for the Azure AI Vision service, providing you with a platform to try several service features in a quick and straightforward manner. Using Studio, you can start experimenting with the services and learning what they offer without the need to write any code. And for some features, you can also test them without even create an Azure subscription. And then once you have familiarized with what is the offering, you can use the available client libraries and REST APIs to get started embedding these services into your own applications in different programming languages like C#, JavaScript, Python, the programming language you are more familiar with. So lots of the tasks I just mentioned, we've talked about image classification, tagging, captioning, face detection, object detection, etc. Lots of those tasks can be addressed by machine learning models developed with a traditional approach, which means trained for a specific task with domain-specific data. For example, to be the classifier able to categorize images among different classes, we could train a model using a supervised dataset made up of pairs of images and labels. However, the future of AI, and I would say the present as well, are large foundation models that are flexible, reusable, and that can be applied to just about any domain or industry task. So a foundation model is a machine learning model that is trained on a large amount of unlabeled data from diverse sources like books, articles, and websites, allowing it to be adapted to a wide variety of tasks and responds with facts, grammatically correct text, argumentation, and also a semblance of creativity. So these models capture general patterns and structure of data and aim to replace task-specific models by unifying different tasks and modalities into a single model, eliminating the need to train individual models for different tasks and integrate several models together. I'm sure you heard a lot in the last few months about OpenAI large language foundation models like GPT-3, ChatGPT, GPT-4, that can perform various natural language processing tasks. So they are able to receive as input text and generate text as output. And they can be used out of the box to do today extensive training. So users can interact with these models using natural language type of inputs, which are known as prompts. But similarly, in the vision domain, models like DALL-E 2, which is also available within the Azure OpenAI platform in preview, are trained on huge amounts of image data to be able to generate a new sample image in different styles, from a photorealistic picture to a drawing, for example, using again a textual prompt written in natural language. In this slide, you can see some example. That text you see here, these are textual prompts that have been used as input to the DALL-E 2 model. So for example, by injecting this prompt, an astronaut riding a horse in a photorealistic style, we can get an image similar to this one. This is an example of an output from the DALL-E 2 model. Or using this prompt, teddy bear working on new AI research on the moon in 1980, we can get these images. So not that these images are an output of an artificial intelligence model called DALL-E 2, and they are generated by that model. So they are brand new image generated from scratch through the model is able to do so because it has been trained on a huge amounts of images. Now, the latest Azure AI Vision service, the latest release of the service is powered by a large foundation model. This large foundation model, it has been called Florence, and it is trained on billions of text images pairs. By using universal visual language representations in the form of text image pair data, the Florence model can be easily adapted to various computer vision tasks, such as classification, image retrieval, object detection, and image captioning. Now, Florence significantly improved the vision image analysis capabilities, whose latest version is in preview, and it's called Image Analysis version 4. Including enhanced image captioning and groundbreaking customization capabilities with few-shot learning. What is few-shot learning? So few-shot learning refers to using computer vision algorithms to make prediction based on a limited number of sample images. The goal of few-shot learning is to create models capable of recognizing similarities and differences between images and learning to associate similar pictures with the same labels, much like humans can learn to recognize objects from a small sample of photos. And before the Florence Foundation model's development, you could fine-tune pre-trained computer vision models using the Microsoft Custom Vision service, which enable model training using a minimum of 15 images. Now with Florence, which is a large foundation model that can rely on few-shot learning, users can train models, custom models, using an even smaller minimum of 4 images, and fine-tuning is available also within the Azure AI Vision service. So you don't need to use an ad hoc service as custom vision. So image analysis version 4, as I said before, this is the latest release of the Azure AI Vision service that is based upon the Microsoft Florence model, which is a model developed by Microsoft Research. And this slide showcases or summarizes the main upgrades of the Azure AI Vision tool enabled by Florence Large Foundation model. You can see, for example, that you have an improved experience with image captions, which are accessible through the caption and the dense caption features of image analysis version 4. Both features use the latest groundbreaking Florence-based AI models to analyze an image to understand and generate a human-readable English sentence, describing its content, or a collection of sentences describing all the portions of the image in case of dense captioning. In fact, the difference between caption and dense caption, and we will see this with an example, is that the caption is just a single sentence for an image, an input image, while dense caption allows you to have different sentences describing different portions of the image in details. Then you also can experience a newest image retrieval feature, which overcomes the traditional retrieval approach technique of using labels and tags descriptors manually or automatically assigned to an image, and relies on the more efficient technique of vectorization. Vectorization converts images to coordinates in a multidimensional vector space. So image retrieval empowers developers with the capability to search images using natural language queries, which are then converted to vectors, and the matching result images, and then the model matches resulting images based on semantic closeness. So you should think this as the input in natural language is converted into encoded as numbers, as vector numbers, and then it has something like a database of images already converted in vector numbers, and it is able to compare those images and match the one with semantic closeness in a way that from the natural language query you can retrieve the image you are looking for. This will be more clear when we go to the example. But just to make you aware that this overcome the traditional approach of having tags related to an image and retrieve images through tags. Then we have, for example, the background removal feature, which is again a new feature of image analysis version 4, which is capable of splitting an image into multiple segments or regions to identify different objects or parts of the image. And it basically creates an alpha matte that separates the foreground object from the background in a picture. So for example, when you are analyzing images, it can be helpful to isolate essential elements of an image from the background that could be noisy. And this feature is designed for this kind of application. Then you have video search. So you can also analyze videos, not only static images. So you have video search and summarization capabilities, which uses a combination of natural language processing and computer vision techniques to analyze the content of a video, enhancing safety and security use cases. It can quickly and concisely summarize the main points of a video, and it also allows you to search for specific moments within the video, making it easy to find relevant content. Last but not least, moving to the retail scenarios, we have the product recognition new API that lets you analyze photos of shelves in a retail store, detect the presence of products as well as gaps on the shelves, and get their bounding box coordinates. These could be very useful for application in retail type of scenarios. And in some cases, pre-trained computer vision models may not provide the accuracy or precision necessary to produce the desired results for any of the applications we have talked about. So image analysis version 4 API allows developers to train a specialized model in these circumstances. And the model customization capabilities provided by Image Analysis 4 enable developers to use their own images to train unique custom models specific to their individual needs. The Florence Foundation model makes the Image Analysis 4 models especially effective at few-shot learning, meaning accurate models can be created with fewer training images. And custom models can be created for either image classification or object detection type of task. Great. So now I would like to jump to a demo, to an example. Let me just look at the chat quickly to see if there is any questions related to computer vision or Azure AI Vision Service. Okay, I don't see any question for now. If you have any question, please type them in the chat, and I will be. I'll make sure I can address them throughout the rest of the presentation. So now let's now explore some of those applications in practice, and to do so, let me jump to the Vision Studio portal. I've already mentioned it to you, the Vision Studio, in the introduction. This studio is available at portal.vision.cognitive.azure.com. And as I mentioned before, you can use this studio to test some features in a way to have a practical examples of what you can do with these features, and then be aware of what you need for your specific solution. For example, we have talked about video summary, and I'm now in the video summary and frame locator tab, which enable us to test this kind of feature. Let's see what this means with an example. In this page, I can try the video summary and search feature with video samples. I have here some video samples, or I can also choose to browse in my machine and pick a video I own. For this demo, I'm going to choose the video, recording into a data center room. As you can see, this is a video recorded probably from a security webcam in a data center room. What we can do with this input video is, for example, ask the model, the pre-built model, to summarize this video. So let's run this test, for example. And the summarization output let us know that this video provides an inside look at the activities of workers in a data center environment, while highlighting some noteworthy events. And then you have the list of events here that happened during the video, which could be very useful in security type of scenarios in which you need to, you have hours and hours of videos, and you need to specifically retrieve a frame for a specific event. So for example, from this summary, I know that a worker is seen falling briefly on the floor. So the next test I can do is try to locate specific frame using a search query, and I can create a custom query. For example, trying to retrieving here the moment in which we have seen a man falling down. So let me write a custom query and run the test. And here we are. I have the exact frame in which the worker has been seen fall down on the floor. So this is very helpful, in particular in security type of scenarios, but also in other kind of scenarios in which we have hours of videos to analyze. We can have this service analyze the video streaming for us, summarize the video streaming. Another type of application could be, for example, for meeting recordings. We want to have the highlights from the video for the video recording, or a session recording like this one. We want to have a summary, just like notes we can take from a session. We can use this service for this kind of application. Let's see another example here. Let's go back to the landing page of Visual Studio. And let's go, for example, let's test the remove background feature. Again, I have some sample images I can test here to remove the background, but let's, for example, try to browse for a file. Let's take my headshot here, and let's see what's the result after the service has removed the background. As you see here, the service has been was able to ignore the noisy background here with the St. Peter's Square in Rome and isolate just the shape of the person at the forefront. So again, if you need to analyze and process images and isolate the essential part of the images from a noisy background, you can use this service, and you can test it with your own images if you would like. Awesome. Let's see if we have any specific question again. I'm pausing for a moment to see if there is any question. No, I cannot see any specific questions, so I will come back to the deck. So we have just done demo 1. We have explored some of the features. There's lots of the features to explore on Vision AI, on AI Vision Studio. We have explored the background removal and the video summary and search. I encourage you to go to the Vision Studio and explore other features on your own. But now I would like to do a second demo. This time, this will be more. The first one was a low-code approach. This will be more code intense. We're going to integrate image analysis and generation capabilities into an app, into a solution. But first thing first, let me introduce you with the tech stack we'll be using for the demo. And you can find the code of the demo, as well as this tech stack and other information in this GitHub repo. So if you want to replicate also the demo on your own, you can clone this fork this repository, clone your repository on your local machine, and work with this code on your own. The link is aka.ms/image-analysis-generation-demo. So coming back to the tech stack of this demo. In this demo, I'll show you how to integrate the image analysis for API we have talked so far, and also the OpenAI DALL-E 2 API in a React static web app. So a static web app built with React JavaScript framework. And I will show you also how you can deploy it on the cloud using GitHub Actions. So as prerequisites of this demo, you would need 3 types of resources. We have talked at the beginning that to use Azure AI Vision, you need a computer vision type of resource. Then you will need a static web app resource, which is a service that automatically builds and deploys full stack web apps to Azure from a GitHub code repository. Each time you push commits or accept pull requests into a branch of your choice. So if you want to host your web application to a GitHub repository and then having a continuous integration and development pipeline to Azure, to the cloud, you can use GitHub Actions workflow with Azure Static Web App for doing so. And that's what we are going to do with this demo. And then another Azure service we are going to use is the Azure OpenAI service. So we are going to use an Azure OpenAI resource for image generation capabilities. Note that the access to this service is currently limited through an application process for responsible AI implications. So you can find all the instructions to require access in the GitHub repo, README at this link. And also, if you can get access to it for the sake of this demo, in which we don't really need a production-ready environment with all the security and privacy requirements and guaranteed by Azure infrastructure, you can also rely on the OpenAI public endpoint. An instruction on how to switch from an Azure OpenAI service instance to an OpenAI endpoint is included in the repo. Great. So let's now jump to the web app itself. So give me a moment to come back to the web browser. So you should be able to see my web app now with a very simple graphical user interface. This app provides 3 main functionalities. It displays a warning message if Azure key and endpoint for computer vision or for Azure OpenAI service isn't found. Now I have configured my credentials for the demo, so it is showing directly the graphical user interface. But if you forget to configure the credentials for your services, the app will display a warning message. Then it allows also to analyze an image with the computer vision service by entering here in this text field a public image URL and clicking on the Analyze button. And then it allows you to generate an image with the OpenAI DALL-E 2 model by entering a textual prompt in the text field and then clicking on the Generate button. So we are going to use this image for testing the image analysis capabilities. To start, we will kick off with image analysis. So let's copy this link here to this image, and let's click on Analyze. So as you can see, the analysis has been processed by the computer vision service, and we are going to see in a few the back end of this app, how the service is called. But here you can see the results. So you have the image that has been processed, the URL, and then the JSON, which is basically the response from the service. And you have, for example, the caption result. The service has generated a caption of the image in a human readable language. So in this case, you have a group of people posing for a photo as caption. Then we also have the object, the list of objects detected in the image, along with the bounding box in which the object has been detected. In this specific case, you see in the image there's no object, there's just people. So you can see that the objects detected in this case are people. So you have the bounding box for each people detected in the image. Then in the result, we also have the results from the read API that extracts readable text from images. For the ones who are familiar with the read API of the older version of the computer vision service, you know that you had to do 2 API calls to get optical character recognition results. While now with the image analysis version 4 API, you can have them embedded with all the other insights. Now, in this case, the image doesn't contain any written text. So that's why the result of the read result feature is empty. Next, what we have the dense caption result. So in addition to the simple caption, so the single sentence description of the image, we also have dense captioning, which generates detailed captions for individual objects that are found in the image. And the API returns again also the bounding box of each object found in the image plus a caption. So you can use this functionality to generate description of separate parts of the image. So for example, you can see here a portion of the image represents a man and woman with the children, another portion, a woman carrying a child on her shoulders, another one, a man in a white shirt, and so on and so forth. So we don't just have a single sentence that describes the whole image, but we have multiple sentences describing all the details of the image of an image. Then what we have here, we have tags. We have the results from the tags feature. So the tags allow to identify visual features in an image from a set of thousands of recognizable objects, living things, scenery, and actions. For example, in this image, the tag assigned to this image from the service have been person, human face, smile, outdoor, and there's no just physical objects type of tags, but also emotion, for example, happy or friendship. So every tags that can be that match the content or the context of the input image are listed here. Next, we have the smart crops result. The smart crops feature analyzes the content of an image to return the coordinates of the area of interest that matches a specified aspect ratio. So this is the bounding box of the central part, the core part identified in the image. And then we have people, which is a specific visual features intended to identify people in the images. In this case, the result is very similar to the object detection feature, just because we have just people in this image. But otherwise, if you have objects and people in an image, object detection detect everything, while people detect only people in the image, with again the frame locations where the people has been detected. Great. So now that I've talked a little bit about the image analysis result, with the image analysis feature, we have seen how we can convert an image into a textual caption. But now let's do the other way around. So let's start with a textual prompt and let the OpenAI DALL-E 2 model do the rest. So for example, let's use this caption as a prompt, as an input prompt. So let's paste this here, a group of people posing for a photo, and let's click on the button generate to let the app process this prompt. So again, in the first example, I've converted with the Vision AI service an image to a text type of output. With the generate button, we do the other way around. So starting from a textual prompt, we have generated a brand new image, or better, OpenAI DALL-E 2 has generated a brand new image with also the URL where it is hosted. And now this prompt was quite generic. Better results can be achieved by fine-tuning the prompt to include further details about what we would like to get as input. So you can experiment on your own with more detailed prompts if you'd like. But let me jump, let's have a quick look to the code now. I want to show you how you can integrate those capabilities into your app. This is an app developed in JavaScript using the React JavaScript framework. And you can see that you have, we have here two isolated specific modules, one for the integration of the Azure AI Vision API, and one for the integration of the Azure OpenAI API. At the top of this JavaScript file, we configure the key and endpoints of the computer vision resource. Together with the visual features here, we'll be specifying when calling the service. So you see tags, read, caption, everything we have retrieved also in the results. And then scrolling down, we find also the definition of the main function, which is called computer vision, performing the following task. It builds the final endpoint, this one, which embeds the visual features in it. And then it initializes the URL of the image we'll be analyzing with computer vision service here. And finally, it calls the Analyze Image API, passing the URL of the image to analyze in the body request. So in the body request, we add the URL of the image to analyze. And then we have the call, the actual call to the Azure AI Vision API. And then we have a similar JS file to embed the image generation functionality in the app, hosted in the source folder. As I mentioned before, this demo supports both Azure OpenAI endpoint and non-Azure OpenAI instance. And Azure OpenAI Service API and OpenAI API handles the construction of the endpoints and of the authentication header differently. So if you want to switch from one to another, whether you have access to Azure OpenAI endpoint or you don't have yet, you need to look for the comments, uncomment this line to use blah, blah, blah in the code, and uncomment the code for the service you want to use and comment the code for the other service. Now, once we have defined our two modules for computer vision, for image analysis and image generation, we need to add these components into the app.js file. So scrolling down here, we find the lines of code which displays. So when we enter a file URL, you see that the computer vision function is called, while when we enter a prompt in the text field, the image generation function is called, and then we display the results of the image analysis or the image generation API. Then once you have your React static, your React JavaScript app ready, you can use a GitHub Actions workflow to build a pipeline in a way to deploy this app, doing a continuous deployment of this app every time you push commits to a branch of your choice in your repo. So just to show you how this works, every time, in my case, every time I push, I do a push to my GitHub repo, which is the one hosting the code of the demo, a workflow, a GitHub workflow is executed. And this GitHub workflow, every time, build again my application and release the latest version of my code into the cloud in a way to have the latest version of my code running at this URL. So that's how you can build a pipeline using GitHub Actions to to do a continuous integration and deployments of your code on Azure. I'm looking at the chat to see some questions. So I see a question about, is it readily available from Prasanna? Is it readily available to consume via Azure Cognitive Services? Yes, everything I've showed to you today, both on the portal and on my demo, so on the code, this is available to you as well. The only thing to note is that the Azure AI Vision image analysis version for API is in public preview. So it's available to you, but it's not, I would say, being in public preview, there's some limitations in terms of region availabilities, for example, or in terms of features availability. So for production type of scenarios, I would recommend to evaluate carefully if you can use the latest image analysis for API, or if you should rely on the stable version, the older and stable version of the API. But yes, this is available to you to test. So let's see other question. Has the model been trained on specific domains? Example, medical data from Terry. So no, these models I've used here have not been fine-tuned for any specific domain. These are pre-built models, so I'm using the basic pre-built models both for OpenAI DALL-E 2, so for image generation and for image analysis. But for image analysis, if you would like, you can do that. You can fine-tune the model with your images. And the good news is that you, since you are just fine-tuning on top of a pre-built model, the good news is that you can fine-tune the model using a base of just 4 images of your own data set. Of course, the more and the more, the better is the data set you use for fine-tuning, and also the larger, the more probable is that you get better results. But yes, if you are interested, you can use the image analysis for API to customize a model for your domain. And you can do that both using the API, but also on the Vision Studio with graphical user interface. So let me jump on the slide again, because I would like to remind you also that you can replicate the demo if you'd like. You need, you can do this too, but you need some prerequisites. You need an Azure subscription. And note that if you are a student, you can benefit from a specific Azure for Students subscription. And if you are a professional, there's a trial for you as well. You need a GitHub account if you want to clone my repo, and if you want to build a pipeline for the deployment to Azure. You need Visual Studio Code to clone and run the app locally. And you need OpenAI for image generation capabilities. You can request through the Azure OpenAI form. You can request access to Azure OpenAI service. While if your application criteria doesn't match with the criteria accepted for this service, you can still rely for a pilot to the public OpenAI endpoint. The demo supports both type of services. Just make sure that you switch from one to another by uncommenting the service you are using and commenting the section with the service you are not using. More information are available in the GitHub repo shared, whose link has been shared through the chat. So I would like to conclude with a few words about responsible AI, because I think that when integrating AI in your application, in particular when dealing with generative AI models, which are very powerful, and in particular when dealing with images and videos, it's essential to adopt a responsible approach. And the Microsoft guidance for responsible generative AI is designed to be practical and actionable. It's based on 7 principles. You can learn more going on microsoft.com/AI/responsible-AI. And then the guideline is to plan a responsible AI solution. So identify potential harms, measure potential harms, mitigate them using tools which are available through Microsoft technologies like the content filtering feature for Azure OpenAI, and then operate the solution responsibly. So execute the plan you draft. I see another question from the chat. Can I use SDK instead of APIs? Yes, you can use SDKs as well. The only thing is that the reason why I used APIs for JavaScript is because there's no, it's not available yet, the latest image analysis for API in the JavaScript SDK. But if you want to experiment and you are familiar with C#, C++, or Python, you can definitely use the SDK. And the same for image generation. So I know we're running out of time, so I want to wrap up here and remind you that this is part of the Microsoft Learn AI Skills Challenge experiences. This is not the last Reactor session of the program, so please make sure that you register for the challenge and you don't miss any Reactor session interesting to you. There's lots of topics around different AI domains, not just vision. So make sure you join the sessions you are more interested in, and there's also availabilities for different languages and for different time zones. Thank you all for joining today. Hoping this was helpful, and hope you have a nice rest of your day. Bye-bye. Thank you.
All right. Well, thank you for joining, and thank you to our speaker, Carlotta. That was excellent. If you do have any feedback, we'd love to hear what you have to say. So we have a survey. You can find the link on the screen or in the chat. So if you want to go ahead and fill that out, let us know what you think about the series. We'd love to hear it. But until next time, I think have a great day.